Good morning, friends and dear students. It gives me immense pleasure to be here for my course Flight Mechanics. I am in the process of solving the problems, and in my today's topic is problem solving on descent flight. And you know what is the meaning of descent? I will just explain. I am Dr. Yagya Dutta Dwivedhi, professor from Institute of Aeronautical Engineering, Department of Aeronautical Engineering, Hyderabad, India. As of now, I have covered the topics from Module 1, which is Introduction to Flight Mechanics, which covers the atmosphere, international atmosphere, basic aerodynamics like lift, drag, drag polar, types of drags, thrust required, power required, power available. These are the module 1. If I talk about the module 2, it is a cruise flight which covers the range of the aircraft, endurance of the aircraft, range also in different conditions, altitude, constant speed, constant CL, 3 types of ranges we have discussed. And also we have discussed for the propeller aircraft and the jet aircraft. In module 3, we have discussed about climbing performance, best climb angle, best velocity for the climb, minimum velocity. Then we have also, in module 4, we have discussed about maneuvering flight, which covers the load factor, pull up, pull down, VN diagram, safety margin for aerodynamic zone and the structural zone, VNE, that is never exceed speed, VM, that is maneuvering velocity, maneuvering point, and so on we have discussed. In module 5, we have discussed the landing performance, takeoff performance. In takeoff performance, ground roll, then ground roll distance, then transition distance, climb distance, and so many things we have done. Now, in today's class, we are going to discuss about these are the topics, that is calculate thrust, how much thrust is required, and calculate the percentage of the engine thrust during descent of the flight. So what is the descent? If you take, this is the aircraft. So first aircraft will be running on the ground, which is called the ground roll distance. Then it has to roll, means the nose wheel will be up and the ground wheel will be touching. It is roll. Then it has to transition. In transition, it is acting as a maneuvering, pull-up maneuvering, and after reaching this, it will continue climbing. So these are the 4 stages of the takeoff of the aircraft. Same way it happened for the landing also. So today we are going to discuss about the descent. So what is the, if it is takeoff, then it is cruise. After the cruise, it starts descending for the landing. So we are only talking about that type of phase where the aircraft is about to land. So this we are going to discuss, and we are going to calculate by the help of 2 numericals which we are going to solve today. That is the required calculation of the thrust that we will be observing. So the numerical number 1, the jet aircraft Cessna 560 with a maximum thrust of 13.55 kilonewton and a mass of 7,000 kg is required to descend with a 5 degree of descent angle and maintaining a constant speed. Means there is no change in acceleration. It is unaccelerated flight. because this we have to understand that what is the effect of the acceleration. So if the desired velocity is 250 knot, what percentage of the engine thrust is required for this flight? So first is we have to find out how much thrust is required for this flight. Now the second case, if the air density is constant at 1.1 kg per meter cube, what must be the aircraft angle of attack? So alpha also we have to find out when the density is remain constant. So first here we have to see that what are the things given. So first is maximum thrust is 13.55 kilonewton and the mass of this thing is 7000 kg and the descent angle, this is the 5 degree, and maintaining a constant speed. So speed here is 250 knot. So what percentage of the engine thrust is required for this flight? So it is a maximum. So how much thrust required, and from there we have to find out how much percentage of thrust required. And in the second case, the density is constant and what must be the angle of attack if alpha naught is equal to 0. So these are the things which are given. So we have to first find out the A, that is percentage of the engine thrust, that we have to find out. And we know that during the descent flight, the equation of motion is L minus W cos of gamma is equal to 0, or L is equal to W cos of gamma. And here W is equal to given mass. So mass is given as a 7000 kg into 9.81 into cos of 5 degree. This you will get 68409 Newton. This is the lift. So now we have got the lift. From this lift, we have to find out the coefficient of lift. So I will change here the color. So coefficient of lift. So we know that L is equal to half rho V square S CL. So CL is equal to 2 into L divided by rho V square S, and we know that lift we have find out here. So 2 into 68409 Newton divided by rho is equal to, rho is given as a 1.1 into V is given 250 knots. So 250 into 0.5144 square into area is 31.83. Area is given 31.83 meter square. So we will get here the CL is equal to 0.236. So now we got the CL. So from this CL we have to find out the CD, because thrust is equal to the drag. So now we will find out the drag. And we know that CD is equal to CD naught plus K CL square. So now we will see here that CD naught is 0.02 plus 0.05 0.236 square. So this we will get 0.0228. So we know that drag is equal to half rho v square s CD. So 0.5 rho is equal to 1.1, 250 into 0.5144 whole square into s is equal to 31.83 into 0.0228. It is a CD. So we got the drag is equal to 6601 Newton. And we know that from the equation of motion, that d minus t minus w sine gamma is equal to 0. So t is equal to d minus w sine gamma, and d we have just find out 6601 minus 7000 into 9.81 into sine phi. So here we will get this thing as t is equal to 616 Newton. So now percentage change in required thrust. So we will get here 616 divided by 13,550 into 100. This will come 4.5%. So this is the answer which we required, that it is 4.5%. Now we have to solve another problem, that is the problem B. We have to find out the angle of attack. And we know that this A is equal to CL alpha, which is CL by alpha. So alpha is equal to CL by CL alpha. CL we have find out, and it is 0.236, and CL alpha it is given in the question as a 5.2 per radian. So we will get 0.04538 radian, and this we can make it as 2.6 degree. So this is the another answer which we have got it. Now the third one is here given as a C. So we have to find out the rate of climb. V sine gamma, V is 250 into 0.5144 into sine 5 degree. We will get 11.205 meter per second, or 2208 feet per minute. So this is the third answer. So like this we have got this answer, and we can see here that only 4.5% of the thrust is required for the given conditions, and the angle of attack of this aircraft should be 2.6 degree, and the rate of climb is 2208 feet per minute. So now we will see the next problem, and that we have to find out the. So this is the numerical number 2 which we are going to discuss today in this lecture. That is the transport aircraft Boeing 777-200 with a mass of 200,000 kg and 2 turbofan engine, each generating a sea level thrust of 342 kilonewton, is required to descend from 12,000 feet to 11,000 feet. So the aircraft is descending. In this descending flight, the airspeed should be decreased from 195 to 185 meter per second when a 10-mile horizontal distance is covered. Determine what percentage of engine thrust should be employed at the beginning of this descent. Assume that the deceleration in the z-axis is 0. Other characteristics of the aircrafts are given as area is equal to 427.8 meter square, B is equal to 60.9 meters, CD naught is equal to 0.02 and E is equal to 0.87. So these are the problems which are given for our question. In this, the mass of the aircraft is 200,000 kg. We have the two turbofan engine. So here we have to see that turbofan engines are utilized. The descent is from 12,000 feet to 11,000 feet. So at 12,000 feet, what is the density? And at 11,000 feet, what is the density? Total distance which is traveled is 10 miles, which is given in the problem. So we have to now solve this problem. We have to now see it that okay, how we should go about. So we know that the distance, actual distance x is equal to under root h square plus d square. So we can find out that it is 12,000 feet plus it is 10 miles. So we have to convert this 12,000 feet square plus 10 mile square. You will get here 16096.3 meter. So this is the our in meters, and at 12,000 feet the density is 0.849 kg per meter cube, and this is the distance in flight direction x. So it is vertical and the horizontal. So now we have to find out the x deceleration. So deceleration ax is equal to v2 square minus v1 square by 2x. So v2 is 185 square minus 195 square divided by 2 into 16096.3. So you will get minus 0.118 meter per second square. So this is the acceleration which we have got. So if I make the diagram, it is like this. It is a 1000 feet and this is the 10 mile and this is the gamma. Aircraft is from here. It is like this. This is the aircraft. It is gliding like this. So this angle by figure gamma is equal to tan inverse 1000 feet divided by 10 mile. This will be 0.01 radian or this will be 1.085 degree. So this gamma is equal to 1.085 degree. So your aircraft is very small angle. It is going like this, very small angle. It is nearly 1 degree. Now we have to find out the factor K. and we know that K is equal to 1 by pi aspect ratio into E. 1 by 3.14 aspect ratio is 8.6 and E is equal to 0.87. So K we are going to get is equal to 0.042. So this we got the K. So now forces in the direction of forces in Z direction of the aircraft. So L minus W cos of gamma is equal to M AZ. AZ is equal to 0. So L minus W cos of gamma. L is equal to W cos of gamma. And W is 200,000 kg into cos of 1.085. So this lift we are going to get 1960978 Newton. So we got the lift. Now we have to find the lift coefficient. Now we have to find lift coefficient, that is the CL, and this CL is equal to 2L divided by rho V square S, and this 2 into 1960978 divided by 0.849 195 square 427.8, you will get 0.284. This is the CL. So now we got the CL. From this we have to get now CD. Now to find the total drag coefficient of CD, and we know that CD is equal to drag polar CD naught plus KCL square. CD naught is 0.02 plus 0.04 K into CL is 0.842 square. So you will get CD is equal to 0.0234. So we got the CD. From this CD we have to find out the drag, and from this drag we have to find out the thrust. So now this drag is equal to half rho V square S CD. Okay, so half 0.5, rho is 0.849, velocity is 195 square into 427.8 into 0.0234. So this drag you will get 161664 Newton. So we got this drag. Now the required thrust. Now this required thrust we have to find out. So we know that for the descent flights, T plus W sine of gamma minus D is equal to MA. So T is equal to D minus W sine gamma plus MA x in x direction. So if I am putting this value of drag 161664 minus W is 200,000 into 9.81 into sine of 1.085 plus M is equal to 200,000 into X is equal to minus 0.118. So here you will get thrust is equal to 100,916 Newton. So this much thrust is required for this operation. As per this case, however, if you see that as per the problem, however, given max thrust of the engine is at 12,000 feet is, we know that T available is equal to T naught rho by rho naught to the power 1. Here we have the 2 engine, 2 into 342,000, 0.849 divided by 1.225. So you will get 474025 Newton. This much thrust is available. Now we have to find out the ratio of thrust required to thrust available. So T required by T available is equal to 100,916 divided by 474025. You will get 0.213 into 100. So 2.13 21.30 percentage. So only 21.3 percentage of the available thrust is used for this flight condition. So this is your answer. Okay, so these are the references which I have taken: Aircraft Performance and Design by the Anderson, International Edition, McGraw-Hill's, first edition 1999. SL by ME, Aircraft Performance Theory and Practices, AIA Education Series, AIA. Any questions, you are welcome to ask. My email ID is yddwivedhi@gmail.com. Please do like and subscribe my channel. Any query, please give me the comment. If you have anywhere I might have done the mistake, please do write me in this mail. Please like my channel and subscribe. Thank you very much for the joining. Please be tuned for my next lecture.
Like, share and subscribe. Hit the bell icon for more updates.